Good day, Miss. My name is Rachel, and today I'd like to present a group assignment Agriculture Monitoring System. Agriculture is an important sector of global economy, providing food and resources for billions of people worldwide. However, climate change and inexperienced farmers present significant challenges to the industry's sustainability and productivity. In response, a comprehensive agriculture monitoring system that leverages AWS can provide farmers with real-time data and analytics on environmental conditions to enable informed decision-making and increase crop yields while mitigating risks. In summary, the proposed agriculture monitoring system using AWS will provide farmers with a comprehensive tool to monitor and optimize their farm's environmental conditions and resources, mitigate risks, and increase crop yields. By leveraging AWS cloud computing and data management services, the system will provide reliable, scalable, and secure data processing, analysis, and visualization, allowing farmers to make informed decisions based on real-time data and insights. Ultimately, the proposed system will help farmers adapt to the impacts of climate change and support sustainable and productive agriculture. Next, I would like to present the problem statement for this agriculture monitoring system. The first problem statement is climate change. Climate change is one of the most significant environmental challenges facing the agriculture sector today. The Earth's climate change due to increased greenhouse gas emission caused by human activity. This climate change is causing more frequent and severe weather events including drought, floods, heat wave, and extreme temperature which pose significant risks to crops and farmers' livelihoods. These extreme weather events can destroy crops, damage soil quality, and increase the risk of pests and diseases, leading to significant losses for farmers. Furthermore, climate change is causing a shift in the geographic distribution of crops, making it challenging for farmers to predict and adjust to changing conditions. The second problem statement will be inexperienced farmer. Inexperienced farmers are another significant challenge facing the agriculture sector. Many small-scale farmers need access to modern farming technology and techniques, making increasing their productivity and profitability difficult. They may also need the knowledge and skills to make informed decisions on soil and water management, pest control, and crop rotation. As a result, inexperienced farmers may need to maximize their yields or utilize their resources more efficiently. This inefficiency can lead to increased production costs and reduced profits, making it difficult for farmers to stay in business. Inexperienced farmers may also be more vulnerable to crop failure, pests, and diseases. Therefore, the proposed monitoring system using AWS aims to address the challenges faced by inexperienced farmers and climate change. In this AWS Smart Agriculture Monitoring System, one of the primary objectives is to allow the farmers monitor the condition of the farm. This includes keeping track of various factors such as soil pH value, temperature, and humidity. To achieve this objective, the system utilizes sensors and IoT devices that collect data in real time and transmit it to farmers through their mobile devices or laptops. This enables farmers to stay informed about the condition of their farms even they are not physically on the farm. Overall, the objective of enabling farmers to monitor the condition of their farm is essential in ensuring the health and growth of their crops. With the help of AWS Smart Agriculture Monitoring System, farmers can make informed decisions and take proactive measures to ensure that crops grow in a safe and healthy environment, ultimately leading to increased productivity and profitability. The second objective of this project is to allow the farmer to be notified when the farms are in critical conditions, for example, the presence of any pesticide in the farm. This is achieved through the use of advanced sensors and IoT devices that continuously monitor the farm's key environmental parameters such as temperature and humidity. By analyzing the real-time data collected by these devices, the system can detect any abnormal trends or patterns that may indicate a potential threat to the crop's health and productivity. Once a critical condition is detected, the system immediately sends out notifications to farmers via email, enabling them to take prompt actions and mitigate any potential change. This proactive approach to farm monitoring empowers farmers to minimize their losses and protect their investment, ultimately leading to increased profitability and sustainability in the agriculture sector.
Good day, I'm from Group 15 and our topic is Smart Agriculture Monitoring System. And this is our architecture diagram. First, we will utilize the AWS IoT core to connect various types of IoT sensor, such as temperature, humidity, and pH value. The data collected by this sensor will be sent to the AWS IoT core for processing, which can be tested using the MQTT test client. Once the data received by the AWS IoT core, the Lambda will be triggered and will process the data and store the data into the DynamoDB and S3. So the data is already sent into the AWS IoT core. Next, for the Lambda is triggered, and the data from the AWS IoT core will send into the DynamoDB. So the DynamoDB will receive the data and store inside the table, and the data will include the ID, sensor type, timestamp, and the value. So next, for the Amazon S3, the data in S3 is used as a data source for QuickSight to generate the data visualization. So this is the example of export.csv, which we'll use for the QuickSight. Next, for the QuickSight, the QuickSight will consist of the total number of temperature sensor, humidity sensor, pH sensor collected, and temperature, pH value, and humidity sensor increased by the daytime, and average of value by temperature sensor, humidity sensor, and pH sensor. Next, for the average temperature, humidity, pH value by the timestamp, and lastly, for the average temperature, humidity, pH value per hour. Next, once the data from the IoT sensor is processed by the Lambda function, it can be forwarded to the Amazon SNS. SNS can be used to monitor the value and alert subscribers in real time if the readings exceed or fall below the desired threshold value. In our Amazon SNS, we have 3 topics, which are humidity sensor, pH sensor, and temperature sensor. This is example when user receive the warning message. For example, if the pH value gets too high or too low, SNS can notify the subscriber. Next, for the cognitor. Cognitor will be used for secure authentication and authorization, ensuring that only the authorized user can access the data. Next, we will click on the View Host UI, and user will be redirected to the sign-in page, and user can click the sign up button. Next, user need to enter their username, email, and password. Then user can click on the sign up. In user tab, the user will be shown. Next, for the Amazon Simple Email Service, which known as SES, which is used to verify the user email. Next, for the Lambda is to trigger. Lambda is trigger and will send the data to the user. So we write the code in the Lambda to send the data to user in the user pool. So the user in the user pool can get the data which obtained from the IoT sensor. If there is any change in the data that's stored in the S3 bucket, the data will send to the user through the email, which the user can download the .csv file of the data. So after the user click the link above, the link in the email, the export.csv will be downloaded, and user can view the data which get from the IoT sensor.
I would like to demo the another part of the projects. So this is our cameras. We use the IoT core to create a cameras under the things. And for that one, after we upload the image, it will straight away send to the store inside the S3 buckets. After that, we also create another bucket inside the S3. That one is used to store the image and from the recognitions. We store some image and train the datasets in order to do the comparisons. So once the image uploads from the cameras, and it will send to the recognitions to do the comparisons. If the image has the higher accuracy with the dataset inside the recognitions, then it will send the notifications to the farmers through the SNS, and for that one is to notify them the pest is being detected. So we can see from our IoT. So this is our IoT things. We create one called IoT camera. For that one is we also download of the certificates and put inside the another parts. So for the S3 buckets, we create the two S3 buckets. So for the first one is this one. This one is used to store the IoT camera images. So once the IoT upload the image, it will straight away come here and like this is all our past image. And for another S3 bucket is this one. This one is the custom labeling, and custom label is come from the recognitions. So we put some image here to train the data sets. So we can see is all the picture and image here. So for our camera lambda inside lambda we trigger with the S3, and that one we use to retrieve and send the image between the S3 bucket and the recognitions. So here is our recognitions. So inside our recognitions, we can see the dataset we train here. These are the dataset we train. We use the custom labels. So, and then for this one is our SNS. We put two email address in order to notice the farmers once the pest is being detected. So we can try to test it first. So we test the lambda code. When we test it, then all the data will be all the image will do the comparisons between the S3 image from the IoT and the recognition datasets. So you can see like the bee is being detected and the confidence is very, very high. So we can go to the CowWatch. So inside CowWatch, we click the first one, the camera lambda, and we can see the latest one. So we just click here. Inside here we can see like the animals, like the bee is being detected is an insect. Okay, so beside we also can receive the SNS message through the emails. So this is the latest one. So it will alert the farmer that the pest is being detected, and once they receive the email, then they can straight away to check the funds in order to do the fast response. So that is all from me. Thank you.